Hello, we are Team 26060 from the University of Arizona Mining and Mineral Resources. Our team competed in the SME Metallic Design competition, taking on the role of a third-party engineering consulting firm known as On the Rocks Consulting. Our project focuses on the Arhuaco gold deposit located in Colombia, where we developed an integrated mine plan, processing flow sheet, economic evaluation, and sustainability roadmap to maximize project value while maintaining environmental stewardship. The Arhuaco project is a proposed open-pit gold operation. Based on our analysis, the project generates a post-tax net present value of approximately $820 million, an internal rate of return of 23.8%, and a payback period of just under 4 years. Our primary objective was to design a technically feasible and economically robust operation that prioritizes early extraction of high-grade material, efficient material movement, scalable processing, and responsible closure planning. The mine life is 25 years, divided into 6 phases to optimize cash flow and manage operational risk.
Our design is grounded in a detailed geologic and economic block model. Synthesizing our block model required the use of Excel to clean and compile drill hole data using assays before it's uploaded to Hexagon's MineSite 3D software program, which is used by mining engineers worldwide to design and plan mine sites. Our geologic model interpolates gold grade distribution using thousands of meters of assay data pulled from rock core just like these across 120 drill holes throughout the property. This information is then limited by structural controls on mineralization using geologic reasoning. We then applied economic parameters to generate an economic block model like the one seen behind me here, used for planning. These factors included gold price assumptions, mining, processing, and general administrative costs, and recovery factors from metallurgical testing. Each block was then assigned a net value within Hexagon MineSite's 3D program, allowing us to refine cutoff grade to further optimize the value we get out of our site, classify ore versus waste, considering optimal cutoff and resource definition, and spatially prioritize high-value zones in later pit expansion sequencing. This economic block model directly informed pit optimization and sequencing, ensuring that early years target the highest margin material.
Our pit design consists of 2 primary deposits, Whiskey in the north and Margarita in the south. We use conventional truck and shovel mining due to deposit geometry, production scale, and flexibility in selective mining. Some of our key parameters include bench height of 15 meters, an interramp slope angle of 55 degrees consistent with our geotechnical constraints, and a haul road design optimized for productivity and safety to the shortest haul distance. The mine plan was developed in Hexagon MinePlan 3D with a strong emphasis on the first 4 years during the ramp-up period. We prioritize high-grade zones in the Whiskey Pit to accelerate revenue generation and reduce financial risk. Pushback sequencing was designed to minimize stripping early, maintain consistent feed to the plant, scale equipment fleet linearly, and minimize capital and operating costs early on.
Our phased approach ensures smooth operational scaling. In early years, we focused on the Whiskey Pit, which will allow the project to build necessary infrastructure and train staff while operating a small, extremely efficient pit. Whiskey Pit has some of the lowest stripping ratios on site and offers great gold grade, allowing the project to generate capital for the future. Then we will move to the Margarita Pit, our big main pit, which has lower gold grades but has a whole lot more ore. Thanks to the early mining in the Whiskey Pit, we will be able to produce needed capital to cover the costs associated with the increased mining rate during this phase of the project. This strategy improves project resilience, gold price fluctuations, and operational variability.
Economic valuation of the Arhuaco project is based on a selected commodity price of $3,800 an ounce. Gold price has not been this low since September of last year, and it has averaged over $4,500 an ounce so far in 2026. At the selected commodity price, the project has a discounted NPV of $820 million, an internal rate of return of 23.8%, and a corresponding payback period of about 3.75 years. And for reference on how conservative we went with our gold price estimate, the average of this year's gold prices would result in an NPV of over $1.7 billion. NPV analysis includes all capital and operational costs incurred throughout the life of the project, including equipment, infrastructure, maintenance, as well as mining costs, processing costs, and estimated closure costs. Sensitivity analysis was conducted to determine which factors were the most influential on the net present value of the project. Results indicated that the price of gold is by far the most influential, followed by mining costs, processing costs, and lastly, capital costs. Excuse me, I'm gonna have to take that. Again, man? What could it possibly be?
Hey guys, want to check out my lab? Welcome.
Our mine will be built with modern and technologically innovative designs. But wait, let me put on my PPE real quick. Our processing flow sheet is designed to maximize gold recovery while maintaining operational efficiency and reducing our environmental impact. In fact, our improved designs allowed for 100 times less cyanide to be used in comparison to conventional methods. Ore from the open pit is first crushed through a jaw crusher and a cone crusher, then sent to a two-stage grinding circuit with a SAG mill and a ball mill to reach a final grind size of 75 microns. From there, the slurry enters flotation where gold-bearing sulfides are concentrated. That concentrate moves towards leaching and carbon pulp, where gold is dissolved and with cyanide and absorbed into activated carbon. Gold is then recovered through elution, electrowinings, and smelting to produce ore bars. Finally, tailings are detoxified, thickened, filtered, and dry stacked, with over 90% of processed water recovered and recyclable, reducing freshwater and environmental discharge.
Oh, On the Rocks Consulting implemented environmentally sustainable practices to ensure proper stewardship of the environment during the entire life of mines. The key features include a water management system with treatment and reuse of the water, lime neutralization and staged acid addition for water quality control, reverse osmosis for polishing discharge water, and a tailings thickener and filtration system. We propose a filtered tailing system to reduce water consumption, improve geotechnical stability, and minimize long-term environmental risk. Closure planning includes landform recontouring, revegetation, and long-term water treatment where necessary. These measures ensure compliance with environmental standards and reduce closure liabilities.
In summary, our design offers a technically sound, economically viable, and environmentally responsible approach to mining operation.
This in-depth approach is exactly why our team placed first in the nation for the SME Metallic Design competition. We are On the Rocks Consulting, raising the bar for mining solutions.